Hi, my name is Konrad Kollnig, and I'm a current PhD student at the Computer Science Department of the University of Oxford. Together with my colleagues, we analyzed privacy in iOS and Android apps at scale because we thought that's a rather important gap in the existing literature. It's an open secret that app privacy problems are widespread. There's been a lot of research on Android and Google Play on that topic. And for example, a recent study from our research group found that even after the introduction of the GDPR, this massive data protection privacy law in the EU, data sharing with Facebook and Google remains widespread in Android apps. Meanwhile, there exist very few studies on app privacy on iOS, and this is despite the fact that iOS is actually the most widely app ecosystem in the US, which arguably warrants a look into this ecosystem by itself and not just be like, yeah, you know, we look at Android and so iOS is probably going to be similar. There are some distinct characteristics about iOS, and so we think it's important to look at iOS and develop the right methodology to do that. Interestingly, the last large-scale study was done nearly 10 years ago on iOS app privacy, and this is the famous Protect My Privacy paper, which I recommend everyone read if you've not done it. And then we've also been motivated by Apple claiming privacy, that's iPhone, in its marketing campaigns, and thereby suggesting that Android performs a lot worse in terms of privacy. And that also explains our title, iPhone's really better for privacy, that's playing a bit with that marketing. Crucially, we did our study before the introduction of the ATT and the and iOS 14, which promised to improve user privacy, were introduced last year. We did a follow-up study. I'm going to comment on that later and how it might have changed some of our results. Maybe before we go into our methodology and the findings, briefly, key reasons for lack of iOS app privacy studies in the past. First of all, iOS is a rather closed up proprietary ecosystem, so it tends to be pretty difficult to do anything with it if Apple doesn't explicitly permit it. Moreover, every single app that's downloaded from the iOS App Store is encrypted with Apple's Fair Play DRM system, and that really makes app privacy research pretty hard on iOS. And partly as a result of the first 2 points, there currently really lack ready-to-use, publicly available app download and analysis tools for iOS. And motivated by the lack of existing tools, we decided to just build our own thing, which we call platform control. It allows the analysis of iOS and Android app privacy at scale. It's open source, it's publicly available, and we hope it's going to be helpful for follow-up studies. How did we go about analyzing app privacy in our paper? First of all, so we generated a large data set of apps. We explored what apps are on the Google Play and Apple App Store with existing tools and found about 560,000 apps. In this exploration, we downloaded a random sample of 12,000 apps per platform from this larger data set. To download apps on Android, we used the existing gplay tool. On iOS, we developed our own thing, which we publicly share. Having downloaded a lot of apps, we then set out to investigate potential privacy problems with these apps. We first did a very common thing, that's commonly done in the academic literature. We looked at tracking libraries and apps. On Android, we used these sort of existing Exodus privacy database of tracker library signatures. on iOS app, we sort of replicated this from Android and sort of created a new database, the first of its kind database of tracking signatures on iOS. Permissions are meant to regulate data flows in mobile apps, which is why we looked at apps manifest files to understand whether and to what extent apps on iOS and Android request permissions. As many of you know, the sort of code analysis I've described up until now comes with a range of limitations, specifically that you never know whether what you find actually happens in practice. And so in addition to the code analysis, we did a network traffic analysis in the usual way, disabling certificate pinning using the open source MITM proxy tool to sort of collect network traces and then sort of identify problematic PI and hosts, contacted hosts in the network traffic. And then sort of in a subsequent step, we combine the insights from the code analysis and the network traffic analysis through the X-ray 2020 database from our research group. We used the state of the database contained information on the networks of tracking companies, which tracking company owns which other tracking company and in what country they are based. And so we combine the insights into contacted tracking domains and include tracking libraries with the X-ray 2020 database to understand which companies receive data. And since privacy is pretty complicated, we didn't just put forward a single measure to characterize privacy, but rather sort of came up with fine-grained app privacy footprints to characterize apps privacy practices. Oh, and as I mentioned, all of this is open source, publicly available, and we hope it's going to be used in follow-up studies. As for our results, we made 3 main findings. First of all, we found that tracking is prevalent on both iOS and Android, although on Android, advertising-related tracking tends to be more common, which obviously can be more invasive if tracking is conducted as part of real-time bidding and then data is really put up in an auction. Interestingly, we found that iOS apps tend to request more opt-in permissions, and especially in children's apps that can be concerning, as I'm going to comment on in a second. And then last, we found rather many violations of US, EU, UK data protection laws, such as the use of tracking without consent, the sharing of PI with third parties without parental consent, which violates COPPA in the US, the kids privacy law, and all of these things. The right-hand side of the slide shows a visualization of the data flows from apps to companies to countries. It's not a super surprising picture. We see that Alphabet, the parent company of Google, sort of gets most data from mobile apps anyway, and that Apple is also involved in sort of the app data collection, and then this is followed by Facebook. What's also quite interesting, though not thoroughly surprising, is that the US are sort of the country that receives the most data from mobile apps. Very briefly, I'm going to highlight 2 interesting further findings. One of them is that kids apps on iOS include the location permission a lot, 7 times more often than on Android. iOS apps more generally also contain the location permission a lot and more so than on Android. This doesn't mean that they share location with third parties more often, but previous research suggests that this may indeed be the case. We also found rather frequent sharing of the advertising ID, this sort of cross-app user identifier with third parties and even children's apps. So that's pretty concerning. And well, as we find in other parts of our paper, advertising-related tracking seems more common on Android, and as a result, the ad ID is also shared more often on Android than on iOS, it seems. Apple introduced a range of new privacy measures with iOS 14, and we didn't look at that in the present paper, though we published a follow-up paper with the same methods, and this finds that tracking continues, and so the extent of tracking continues in the same way. However, the quality of tracking seems to have changed. Tracking seems to have gotten harder on iOS, and so that's why Apple's new privacy measures seem to go in the right direction. Thank you very much.